Saxon Algebra 1, Lesson 58, word problems. Students, we learned that there's a thing called a frickin' formula. It's when you use a fraction to divide up a group of things, like the bag of Skittles that your mom just poured on the dining room table and told you that you could have 1/3 of them. You count out your share, and that is the special group that you get to eat. We can also use a decimal to divide up a group of things. If your mom tells you you can have 0.276 of the Skittles, then you can do a calculation to find that out. We can also do it with percents. We just have to remember that the percent goes over 100, right? Because percents are always a fraction of 100. And it works the very same way. What we're going to do is we're going to practice some of this form, which are, I mean, to be honest, they're my most favorite and they're the most popular kind. We do the most of them. And what we're going to do is we're going to have a little story to go with them, which honestly I think makes the problems easier and more fun. And you know I'm all about fun. 58.1. Kathy, John, and Susie stepped right out of the 60s, and they have only 20 chickens left. If they began with 80 chickens, what percentage of the original flock remains? All right, so they must live on the prairie or something. I don't know. See, that's why I like these problems. They give me something to think about. Who are these people? Are they children? They sound like children, but you know, Kathy, John, and Susie. Seriously, you guys, those are such 60s names. I can't even take it. They started with some chickens. That was 100% of their original group, right? Then something happened. And some of the chickens left. And some of the chickens stayed, right? Let's get those numbers. They have only 20 chickens left. Oh, I shouldn't say left. I should say these went away because that's confusing, right? Stayed or remained. These are the chickens that they have left, right? Left can mean two different things. The ones that you have left or the ones that left your barnyard. Oh my gosh. Okay, they have only 20 chickens left. That's the ones that remained, 20. If they began with 80 chickens, what percent of the original flock remains? Okay, well, we can figure out really easily how many went. We know that this many went away, right? We want to find the percentage over here. So what we do is we take this, the percentage over 100, which we don't know, times the original group, which I'll put over a 1, equals the special group. Does that make sense? That's the missing one, times the original group equals the remaining group, the chickens that are left. That's so, the word is crazy there. I'm putting those over a 1 just to make it easier to do the math. Maybe it'll be easier. I don't know. I'm just throwing them in there for fun. It makes my eye happier to see that everybody is a fraction and there's none of this weird floaty number stuff. I don't like that floaty stuff. Okay, so now there's our variable. We need to get rid of this nonsense. So we'll multiply by the reciprocal, 100 over 80. Same to both sides. Hannah Cranny, you guys know, she's the former student I had that insisted that everything had to be fair. She was the youngest of 4 kids. Their family was the same age as my family, so we did tons of stuff with them. And Hannah was always making sure that it was fair because she was the youngest. And you know how that is. If you're the youngest in your family, you can get run over really fast. So you have to be in there advocating that everything's got to be fair. She studied social justice in college, which I thought was really great. And she worked in ministry, but I noticed she's recently become a real estate agent. So I don't know what that means. I'll find out. But a couple years ago, 5 years ago by now, Hannah Cranny came and talked to some of my students once. Which was so great. I'm like, this is Hannah Cranny, you guys. And she's like, you know, always do to one side of the equation what you have to do to the other. Okay, so now P is by itself, and we just have to simplify this. Well, that should be pretty easy. 20 goes into 84 times. That becomes a 1. 100 divided by 4 is 25. So that tells us that P equals 25%, right? So this represents 25. And so that tells us this must be 75%. Even if the problem doesn't ask us, we always figure out all the parts of the problem. The original amount is always 100%, and then we find the percentages of the split group, and we find the numbers of the split group. So in the end, there should be 6 pieces of information. That is part of the problem. John makes this line, in these lessons, John makes this line curvy. I make it straight. It doesn't matter. Don't let that worry you. All right. The next one. Ready? There are 3 of these. Mimi and Jim have 75 thingamabobs. They want to give Hal 20% of them. How many thingamabobs do they give to Hal? Okay, Mimi and Jim. I could not make this up. It's too great. Here's Mimi and Jim's thingamabobs. They have 75 thingamabobs, and that, as always, represents 100%. They want to take their collection of thingamabobs. This is like the before and the after. And they want to split it. Some they're going to give to Hal, and some they're going to keep for themselves. Okay, so those are the only 2 options. They want to give 20% of them to Hal. Okay, so this is going to be, usually I write the number, the percents right there. I'm going to write them on this side because I have a little more room in this diagram. They want to give 20% to Hal. Well, we can tell right away that means they're going to keep 100%. So we're going to find both of those numbers. Let's find this number first because that's the one we're interested in. I'm writing my formula again. Please make sure that you write your formula again on every page of your homework where you're using it. Please make sure on tests that you always write your formula. I took points off if you didn't. I felt like a big fat meanie, but I have to convince you that I'm serious. I'm going to start taking points off in review problems if you don't write your formulas. Oh, I'm so mean. I can't live with it. All right, we're going to use this and set it up. 20%, we want this number. So 20 out of 100 times the of number, which is that, equals what number? Which goes right there, right? Okay, all the numbers are on the left, so all we have to do is simplify. That goes 3 and 4, right? Divide both by 25. 20 and 4, we can simplify that. That just becomes 5 and 1. 1's on the bottom. So that means that 20% equals 15. So that's how many thingamabobs we're going to give to Hal. Cool. Now, how do we find out how many we're going to keep? Well, we could do the same calculation. We could say 80 is the new percentage over 100 times the original group, 75, will give us the special group. We could do it and it would work, but you know what? We can just subtract 2. 75 minus 15 is 60. So that's the short way. This is what the problem was actually asking us, is how many things we were going to give to Hal. So there we have it. Now, in these 2 problems, the percent that we were using was less than 100%, right? Here we had 20 and 80% we were talking about. Here we had 75 and 25. And in both of these pictures, we had the original group of something, and then we took that and we split it, right? We divided that group into 2 parts. Now, these have a very specific name. If you can use a lot of imagination, please, you can imagine this to be a scoop of ice cream with hot fudge on top of it. Please, do you have that much imagination? Okay, I call these ice cream sundaes. This style of problem where we take a group and we split it, and the percent is less than 1/2. However, there is the other kind of problem. I feel like we've already talked about this year. To tell you the truth, I talk about this every year, so I kind of forget. This is the peanut style. And this is where we have a group of something, and it gets bigger. And this is what I call the peanut. It would be the peanut in the shell, right? Not the loose peanuts. But this is the peanut in the shell style of problem, also known as the toddler baby Jesus, right? Because there he is wrapped in his swaddling clothes. He's happy, okay? Either way, if our percentage is greater than 100, that means we take our original group and it grows, okay? So we've done 2 of this style. Now we're gonna do 1 of the growing kind. And these ones are tricky. You have to think carefully about what the words are telling you. And it can be kind of a word trap. This is our last problem for this lesson. Example 58.3. Here we go. Sit back and let me read you a little bedtime story. Bo and Christy hide 600 raisins. This is 60% more than they hid last month. How many raisins did they hide last month? Oh, just let the weirdness of this soak into your brain for a second. They're hiding 600 raisins, and that's more than they hid last month? Oh my word, why are you hiding raisins? That's just nutty. Okay, but we know that it's a toddler baby Jesus because the amount last month has gotten even bigger. So last month was 100%. That stands for month, all right? It says they hide 600 raisins. This is 60% more than they hid last month. So I know this is this month, and it's 60% more, so that means it's the 100% from before plus the 60% more. So this represents 160%. Okay? 60% more means we added on to the amount of last time. We're supposed to find out this number. How many did they hide last month? All right, P over 100 times of equals is, our percentage is 160 over 100 times the of number, the original number. We don't know that. So I'm going to put what number, put it over 1, equals the special group, which is the new number, 600. And again, I'll put it over 1. All right, we're trying to isolate him. We'll multiply by the reciprocal. Okay, so far so good. Now, this has all gone away. We need to simplify over here, right? Now, what I'm going to do is I'm going to say, let's divide top and bottom by 10. I can do that by simply slashing off the zeros, right? I'm dividing by 10, both of those. 10 and 16, let's see, this is 2 times 5, and this is 2 times 8. So far, so good. The 5 is done. Can't do anything more with that. 8, I can put into this. Let's divide both by 2 and see what happens. So this will be 300, and this will be 4. Does 4 go into 300? Yeah, because 4 goes into 100, right? Let's just do it like this. 300 divided by 4. It would be 7. That's 28. Subtract 2, bring down, 75 times. Okay, 4 into 375 times. Yeah, that sounds right. Okay, so we've done all the reducing that we can. We've got that down to 1. So now we just have to multiply, what's 75 times 5? 25, 2, 35, 37. So what number equals 375? That is the number of how many raisins there were last month. I think this is a deeply disturbing problem. I want to know who's finding all the raisins, because if they're hiding hundreds of raisins every month and there's not some dog coming along and eating them or something, well, I'm concerned for their health and safety. But there's an example of a peanut word problem. It gives you something to think about. It's a little bit scary, but I hope you understand the math. And that wasn't too much of a heartache, right? All right, you guys, we are done. That is lesson 58. I hope it makes lovely, perfect sense to you as you tackle your homework. And that's all I have to say to you. Thank you. Goodbye.